code demo for the fake news detector for our ECE 5831 final project. So before we go through the code, I'll explain a little bit about the data. We found some data sets on Kaggle, but we found some patterns in the data for both the true news and the fake news that we cleaned up prior to running the code. We removed some of the patterns of text that referred to the city and the news source from the true news, and then we removed the photo by that was at the end of every text article in the fake news.
So first we imported all the libraries that are necessary for running our project. Here we have the Panda, NumPy, Seaborn and TensorFlow, some Keras models files for the pre-processing tags and sequences, then some layers and the matrices for the classification report, confusion matrix, matplotlib, and scikit-learn model selection as in k-fold cross-validation that we have done. In the data pre-processing, as we can see that we have the two different CSV formatted files, fake and true. So we first gonna read those files and define the classes as in fake class as in 0 and the true class as in the 1. Then we merge those two files. We drop the unnecessary attributes such as title, subject, date. Then we shuffle the data set. We reset the index after the shuffling, and we also added the splitting value. So based on the splitting value, the splitting value will be between 0 and 1. So based on the splitting value, we decide to split the data. Then once the splitting value is added to the data set, we try to write the data set to the CSV format, that is our fake news detection data set.csv. As you can see, now the fake news detection data set is already added to our files. Now on the pre-processing, now we're gonna read that data, and let me show you how does this data look. So this is how our text, these are all the text, these are all the articles. This is the class where it says 0, that means it's a fake, and 1, it means the true, and having the splitting value. So on the pre-processing for k cross validation, we just remove the splitting value, and then we decide to work with the text and labels as we try to convert the text into the string. And then for the normal class working, for the normal model implementation, we do it like partitioning the data into the 3 different sets. The first one is the trend data set that contains the 70% of our data. Then there is a validation data set that contains 70 to 90%, that means 20% of the data, and then the 10% is for the tasting. So over here we use the splitting value to do the split of the training, validation and testing data set, and then we drop those splitting value attributes. So here is our CNN model. So in the CNN model, we are running CNN model over here. Let me explain the code meanwhile. So here in the CNN model, so first we initialize the class as in fake news class classifier, in which we have the self as this is the constructor for the class, having the vocabulary size of 10,000 and the maximum length of 500. So in the these are the parameters where vocabulary size and maximum length are those two are used for the one hot encoding and the padding sequences. Those two are the fixed one. So this get passed to the vocab size and the maximum length. Then the model and history, those two things is set as none. In the pre-processing data set, first we get the training, tasting and validation data with the text and label columns. So this method will return the pre-processed training, tasting and validation data set, tuples. So in first we extract the text and labels. So in the trained docs we get the data, text articles from the trained data set, and in the string format. In the label we got the label of the particular records. So in the taste docs, taste labels, validate docs and validate labels, those are performing the same way. On one hot encoding we did perform one hot encoding using that particular documentation. It reads one by one tuple of this trained docs, and then it try to encode it using the particular vocabulary size, that is 10,000. In the padding sequence we did perform the padding at the post and having the max length as in 500. In the build model, as we mentioned previously in the presentation, so in build model we use the sequential method, where it uh, sequence, uh, sequentially use the different layers one upon the another. The first one is embedded, which has a vocab size of 10,000, 8 as in dimension, and the input length will be the length that we given as in 500. In the convention one dimensional, we have the phi as in kernel size, and 128 will be the features that we're gonna filter using the ruler function. In the global max pooling 1D, we did reduce the dimensionality of the input by taking the maximum value over the time dimension for each filter output. Now there is a two dance layer. Those are the fully connected ones. So the first one having the 10 neurons having the activation as a ReLU, and the last one is having the one neuron, which is the output one, giving us the output between the 0 and 1, and that's the probability of the model. This is the model compilation. We use the ADAM as an optimizer and binary cross entropy as the loss, and we use the accuracy as the matrices. In the train model, we train the model, and we try to train the model using the epochs of 20 and using the validation data. These are X validate, and this is the labels for the data. This batch size having the 60 of the batch size. We evaluate the model using the model dot evaluate, and we get the loss and accuracy. We also predict the models based on the X validate. If the value is greater than 0.5, that gives its the prediction as a type of integer, and it generate the prediction value. We generate the report based on that, and we also have the confusion matrix. So this method will return evaluation method will return loss, accuracy, and confusion matrix. The plot matrix will plot the validation and training, accuracy, and loss. The prediction new article will predict the new article based on the given input details. First, whatever the input we get, we try to encode it using the one hot encoded, and the converts the articles as unpadded articles. Then we predict the values, and once we get the prediction, we see if the value is greater than 0.5, that means it's a true, and if it is a less than that, if something else, it's a fake. Then we display the results having the actual article, what's the predicted label, and what's the actual label is there. Now here is the way we first we here is the usage of the whole class. Like how we did it is the classifier having the fake news classification. Class is called over here. It's assigned to the classifier. From this one we're gonna pre-process the data, then we build the model, then we train the model, we plot the matrices, and we evaluate the model, and we predict the 5 different articles on and their labels. So here is the output. As we can see, on 20 epochs it run, and we got the validation loss as in 0.014, and the accuracy is 0.99. We have 632 as positively true values, and 593 as a positive false values. That means this 632 is actually true predicted articles, and 593 is actually false predicted, like fake predicted articles. And as we can see, these are the articles that we assign to the trained model, and we get predicted these results from that. Now with the CNN k-fold cross validation, we again work it like the same way. Apart from that, here is little bit difference is that we have only two methods: build model and evaluate model. Build model will do the same as the way it were doing it previously with the CNN one, and the evaluate model having the details for the loss and accuracy and confusion matrix. So in k-fold cross validation, we take the data, we take the columns having a text and articles and the label column. We extract those data. We did one hot encoding and the padding as well. We initialize the k-fold cross validation and the splits as in k is 5. Then we split the data in the loop till the time it get all the data get all the data points get trained once and validated once. Here we get the average loss and average accuracy based on all the details above, and here is the predictions for that. Let me run this code quickly. So here is the classifier is key for having the same vocabulary size. So though we provide this vocabulary size over here, it take the one that previously defined with the initialization of the class construction. That's a 10,500. This is like the default one. So far we can see that we have done the training of 2 folds, and third fold is just get done. It taking little bit time as it need to run the 5 folds and getting us the loss and accuracy. uh, let's see, it will be in a few minutes. It will see us the accurate results of average loss and accuracy. This is more realistic results because with k-fold it try to train and test each data, train and validate each data points, rather than just doing. When we do the random one, we don't actually able to predict like this. So this one is more accurate, more realistic results with the k-fold cross validation. As we can see, this one is giving us the average accuracy of 98, which is very similar to the KNN, the one that is with the random split, but this one having the more accurate one, and the loss of 0.05. So now let me run the RNN model, and I'm handing over to my friend. She will explain the RNN model and the quick cross validation, k-fold cross validation for the RNN model.
Here's our code to set up the class for the RNN. First, we initialize with some of the vocab size, the 10,000, and the max length of 100 from the input text. And then we set up the model and history to none. Then we have a function for pre-processing the data. So we read in the train data, test data, validate data, the text column and label columns. We convert it into string for each of these, the train documents, the train labels, and then also the validate and test docs and labels. Then we use one hot encoding to create an array for all of these 3 data sets. The one hot encoding converts each article into an array, and each index and value in the array stores which vocab it matches to in the dictionary. Then we pad the sequences, so depending on the longest article in each of these data sets, we match the other articles to it too by adding zeros. Then we return the modified train, test, and validate data sets. Next, we build the model. So here we set up with the Keras sequential. We do embedding with the vocab size in 64, and then we put mask 0 to true so that we ignore the padding values that we added. Then we set up 2 layers for the bidirectional LSTM. The first is of filter size 64, and it returns sequences, which are then used for the second layer with filter size 32. Then we have two dense layers. The first has 64 fully connected neurons, and we use the activation function of ReLU, and then we use one final dense layer for one neuron output. Then we compile the model with the ATOM optimizer, the binary cross entropy loss, and the accuracy metric. For training the model, we use a standard model fit, and we feed in the train and validation data. We use batch size that's defined as default of 20, epochs as a default of 20 and batch size default of 16. Then we evaluate the model. The metrics are loss and accuracy. And we also predict with the validation data as well. We also show the classification report, which includes the precision, recall, F1 score, and support. And we also print out the confusion matrix to understand the true and false positives and negatives. We also plot the results as well, the training accuracy and loss, and the validation accuracy and loss. And we have a function for predicting on new articles, which is from the test data set. So we apply the one-hot encoding for these articles, we pad the sequences, and then we predict with the model. And then we also use the value of the prediction to classify if it's true or fake. If the output is greater or equal to 0.5, then it's true, and otherwise it's a fake, classified as fake. And finally, we print out the results. So here are some lines showing how we run with the RNN class, and the results are shown below. So we train to 20 epochs. Here are the plots that are also shown in our report. The loss and accuracies show some fluctuation in the early epochs, but then it becomes stable. This fluctuation in the early epochs could be due to some overfitting, and we did not need to train all the way to 20 epochs. This is the classification report that shows the precision, recall, F1 score, and support. The results are showing pretty high values, which indicates that it's a good model performance. Our confusion matrix we also show in our report. And then here are 5 articles that we predicted. So finally, we tested the RNN model with the k-fold cross-validation. This is the class for the RNN k-fold. So we initiate similar to above. Then we build the model, also similar to above. And we evaluate. So same thing here, we're outputting the loss and accuracy with the test data, showing some of the predictions, and then also printing out the classification report with the precision, recall, F1 score, and support. And then this is our function for the k-fold cross-validation. So we're putting in the data, some of the columns here. And we used a k equals 5 for our cross-validation. And then similar to above, training to 20 epochs and using a batch size of 16. For each fold, we print out the loss and accuracy. And we iterate through all of those functions, and then we store it in an array so that we can calculate the average loss and accuracy. Here are some of the results shown below. So for the first fold, we had an accuracy of 0.98%, all the way down to, for the fifth fold, we had around 80%. I also wanted to show that we reran some of the code since the previous recordings. So we did have some slightly different results when we reran, and this is the code that will be uploaded to our GitHub. So we saw slightly better results for the CNN. We reached 100 for the accuracy, and then also for the test accuracy, 99.8. For the CNN with k-fold, we reached accuracy of 98.88 for the test data. For the RNN, when we reran the code, we reached an accuracy of 99.85%. These are the plots, and they show less fluctuations than previously. And then finally, I had showed the results for the RNN model with the k-fold. Thank you.